first computer resembling today's modern machine was an analytical engine, a device conceived and designed by the British mathematician Charles Babbage between 1833 and 1871. The computer as we know it today had its beginning with the 19th century English mathematician professor named Charles Babbage. He designed the analytical engine, and it was this design that the basic framework of the computer of today are based on. Now, giving a simple definition of a computer, it is an electronic machine made to process, store, and retrieve data and perform calculation faster and efficiently than humans. Based on the devices used to attain this objective, the process to store and retrieve data. Now, on the basis of this, the computers are divided into five generations. So, talking about the first generation of computers, they were vacuum tubes from 1940 to 1956. The first generation computers used the vacuum tubes as a component of memory and relied on machine languages, the most basic programming language. A vacuum tube is a sealed glass tube containing a near vacuum which allows the free passage of the electric current. These computers were limited to solving one problem at a time. No monitor were there. Output was released in printouts. That is, the monitor were appearing in third generation of the computers. There were no monitors in the first generation. So the input was based on the punched cards and paper tapes. Electronic Numeric Integrated and Calculator was the first successful electronic computer which was developed by the two scientists, namely J.P. Eckert and J.W. Mucci. The other first generation computers were Universal Automatic Computer, Electronic Delay Storage Automatic Calculator, Electronic Discrete Variable Automatic Computers, and Leon's Electronic Office. So this was all for the first generation computers. Now, talking about the second generation of the computers, that is of transistors, the thing that upgraded the entire generation of the computers to a more advanced system was a transistor. Invented in 1947, it converts the electronic signals and the electrical power. The transistor made computers smaller, faster, cheaper, and less heavy on electricity use. The speed of the computer performances depend on the speed of the transistor. In other words, the faster the transistor, the faster the computer. The second generation computers still relied on punched cards for the input and the printouts like the first generation. The symbolic language, assembly language, was developed and the programmer could create instruction in words. High-level programming language, early version of the COBOL and the Fortran were also developed. Now going to third generation of computers, that is of integrated circuits from 1964 to 1971. With the invention of the integrated circuits, the small circuits which can perform the function of the large circuit, transistors were miniaturized and put on silicon chips. The third generation computers were the first computers where the user interacted using the keyboard and monitor and interfaced with an operating system. This enabled these machines to run several applications at once. Functions were based on the monitor memory. Now going further, the major characteristic feature of the third generation computers and the electronic components like the transistor, resistor, capacitor grown on a single chip of silicon, eliminating the wired interconnection between the components. The IC technology was also known as microelectronics. It made it possible to integrate a large number of the circuit components into a very small surface of silicon known as chip. Initially, the IC contained only about 10 to 20 components, and this technology was named a small scale integration. Later, with the advancement in the technology of manufacturing integrated circuit, it became known as a medium scale integration, and ICs were much smaller, less expensive to produce, and more rugged and reliable. Faster in operation, dissipated less heat, and consumed much less power than the circuits built by the wiring electronic components manually. And hence, the third generation computers were more powerful, more reliable, less expensive, smaller, and cooler to operate than the second generation of computers. Now, talking about the fourth generation, that is of microprocessors, from 1972 to 2010, the average number of the electronic component packed on a silicon chip doubled each year after 1965. This progress soon led to the era of the large-scale integration, that is LSI, when it was possible to integrate over 30,000 electronic components on a single chip, followed by a very large-scale integration when it was possible to integrate about 1 million electronic components on a single chip. As a result of the manufacturers were able to reduce the size of the computers and made them cheaper as compared to the other generation of the computers. The progress in LSI and VLSI technologies led to the development of the microprocessors. A microprocessor incorporates various components of the computer such as CPU, memory, input and output control onto a single chip. The computer in this generation were designed to have a microprocessor and some additional storage chips and support circuitry. The Intel P4004 microprocessor chip developed in 1971 and some other popular microprocessor were Intel 386, Intel 486 and the Pentium. The term personal computers became known to the people during this era. During the fourth generation, magnetic core memories were replaced by the semiconductor memories, resulting in the large random access memories with very fast access time. On the other hand, the hard disk became cheaper and smaller, the large in capacity, and parallelly, in addition to the magnetic tapes, floppy disks became very popular as a portable medium. Another significant development during the fourth generation period was the spread of the high speed computer networking, which enabled the multiple computers to be connected together to enable them to communicate and share data. LAN became popular for connecting many dozens or even several hundred computers within an organization. The WAN became popular for connecting computers located at a large distance, and this gave rise to the network of computers and distribute system. Some of the examples of the fourth generation computers are the IBM PCs. Now, talking about the fifth generation computers, that is of artificial intelligence. But before that, the fifth generation computers are based on the ultra large scale integration technology that allows almost 10 million electronic components to be fabricated on one small chip. The the ultra large scale integration technology help in increase the power and the speed of the microprocessor chips, the capacity of the primary and the secondary storage devices to great extent. As a result, the fifth generation computers are faster economically and more efficient as compared to their previous generation. So, for example, Siri of iPhone, automatic cars, robots serving various purposes, all of them are the part of this generation. Artificial intelligence today is properly known as the narrow AI or the weak AI. It is designed to perform a specific task like driving or solving complex mathematical equation. General AI or the strong AI is the aim of today's world, where the machines can perform many functions like humans. Now, a basic definition of the artificial intelligence, it deals with the simulations of the intelligent behavior in computers. In fact, AI can imitate the intelligence of the human brain. Now, John McCarthy is known as the father of intelligence. So, this was a small update on the go.
Hey, if you enjoyed the video, hit the thumbs up, share it and subscribe to MELWYN Joel channel for more upcoming videos.